So hello guys, my name is Oleh, I'm a .NET developer, and today we are going to talk about the C# new feature which is called primary constructor, and with using the existing class, record and struct keyword. So what are the key differences and when this feature can be used. So let's start just from the scratch. So we have completely empty program.cs, and if we will try to build that, we will obviously receive an error that this file doesn't contain anything for the entry point. And here we have the configuration of the project, so it's just the .NET 7 console with the nowbo enabled, and we will look how it can also impact the compiler output. So why we had the picture with the bytecode is just because we will today we will look not only on the C# code but also at the low level and in the IL code of what we are typing. So let's, for example, do such thing like let it be hello world. Okay, and let's try to build just one statement. So to look what the difference is, and here we see the low level output. So we have generated the program class. We're using the compiler services because this class is compiler generated, and we have obviously the constructor. Okay, but here we do not have this var hello. But if we will go to the intermediate language and look at it, we will easily locate that we have just a string of the hello world. So it's just the first conclusion that var in C# is just a syntax sugar. So not how from the beginners think that it's kind of other type and so on. So it's just the syntax sugar wrapping the regular string variable. Okay, and let's proceed with just creation of the class. So let's call it class, and yeah, so let's have just one field and one property. So let it be public property of ID, and let it be the public but the field of the name. So why we have both property and field? Just to show the main difference between them, because we cannot go further until we do not know this difference. Sometimes it's the beginners think that the property and field are almost just the same things, but it's completely not true. So looking in terms just at low level C#, or we can look even in the intermediate language code, we see that a field is just a field. So it's just the same field, and it has this one nullable of 1. So yeah, the property does not have that. So, but this thing is generated just due to this configuration stuff. So if we comment it out and just rebuild the project, and let's look at the updated code, we see that there is no such annotation anymore. So the name is just the name to the C# compiler, but this property transforms from this one both to the field, which is of course private because it's a backend field and it's compiler generated and it's debugger browsable. Okay, and the property does consist of two methods, get and set. So these ones are separate from this backend field, but these ones are the only way to set the value to this field. So not just as a regular field like this. So we can easily, for example, let's create. And for example, yeah, so we can create the new variable of this class type, and for example, if we are going to set the field and property, so for example, we are going to set ID as 1, and for example, name we are going to set as so it means that in this case, if we are gonna, but probably we will not see the difference in the here. Yeah, so we will not see the difference here, but under the hood, for the field, we will just set the value of this one, but under the hood of property, we will call just this set method and we'll set the value of the field just using this method. So, and what is the main conclusion? So, when should we use either field or the property? So, from the practical and theoretical perspective, I would suggest such a thing that field like this one should be used mostly in the performance critical scenarios, because for example, if we're talking about thousands of entities, thousands of operations and so on, so of course the direct access to memory like here will be quite more speedy than the access within the method under the hood, as we are talking about the property. But there are some cases when we probably should use the properties. So these cases include, first of all, such a thing as the project architecture, which being used by a company or customer and so on, because there can be some scenarios in the testing and maybe in the deployment, and in some other cases when there is a convention to use mostly properties instead of fields. Also, the usage of the property instead of field can be a result of using some functionality or the packages. So, for example, the entity framework, because there is only one case how we can set up it to use the field, but it's not very convenient, and it could really lead to the exceptions using some third parties like entity framework bulk extensions and so on. But when we are talking regarding the XML or JSON serialization deserialization, both fields and properties can be used. So it depends just on the encapsulation usage on the project. So either it is strictly used, or it can be or its usage can be limited due to performance. And the second thing is and the second thing is just the concerns regarding this or that use case. So because if the performance is not critical, of course you can stick just with the property, and if the performance does really matter in a particular case, it would be better to use the field. But it was just the some regular stuff, so we haven't began to talk regarding the primary constructor. So, and what does this thing? So in previous, but not previous, but let's better to say in a usual way, we are doing the constructor like this. So we have, of course, we generate this constructor, and here we will get, unfortunately, an error. So why? Because also the very easy concern, but let me show how it looks like exactly. So when we do not have any kind of the additional constructor in the class, so no constructor at all, we see that the compiler does auto-generate the empty constructor, okay, so which is used just here. And if we define at least one constructor like here, So of course we will not be able to compile it now, but let's comment this out, repeat, and let's look at this class. So we see that there is just constructor with these two parameters. Okay, so in this case we can just use the constructor instead of this initialization. So it can be just, yeah, but we have the other arguments order, so yeah, let it be this one. But this is the regular approach in terms of the constructor, but how to use the new version? So first of all, we need to go to the properties, and here instead of #11, which is by default and it cannot be present here at all. So for example, we do not have any long version attribute in the CS approach, but the .NET 7 by default treats this as the #11. But we can select this one called as preview. Okay, and yeah, probably we have modified this file, so okay, let's do it by the hand. Yeah, preview. Okay, let's rebuild, and here we see the, yeah, just this adjustment. So we can easily convert to primary constructor just using this context action. So okay, let's do that just to simplify our life, and let's see what this feature does exactly. So let's look at the compiler output, and we see that it's just the same constructor. So just the same constructor without parameterless constructor. So, and it's just more a brief declaration of this functionality. Okay, and also there is other form of this thing. Maybe you have seen or not. So it can be like this one. Let's call it class 2, and let's provide the example ID, and let's provide string name. Okay, just like this. So it's something like the record which we have seen previously, but this is just a class with the constructor having two parameters, but having no fields or properties at all. So it's not the record. So it can be written this way, but unfortunately it does not have any practical sense, because, for example, let's do the initialization and put a breakpoint here and see how this is treated by the compiler. So, and we see that this class does not have anything at all. So it's just maybe kind of, don't know, so when this one can be used, but still it can be used now. The next case is for example when we are talking regarding the records. So let's create the other testing class. So it would be t class 3, and let it be just a regular class. Okay, and for example here, let's, yeah, we have an attribute. So, and we see that this is just the class with the properties, but and with the constructor. And let's add, not add, but use instead of class the keyword of the record. So we can easily do it just this way, and let's rebuild. So in the pure form, so what does this keyword do? So first of all, for now it's not the regular class, it's a class which has implementation of the equatable interface of this type. So, and what does this exactly mean? So first of all, we have the equality contract. Next, we also have the toString method, so which will print the name of the class, the brackets, and next it will print all the members of this class. So not regarding, let's make it also a field. So, and this one treats both fields and properties just the same way, so like this. Next, it has the operations of equality, inequality, get hash code equals, yeah. So, and all this stuff is generated only because we are using the keyword of the record. So, and next there is the record form of this, yeah, exactly what I wanted to do is the record form like this one. So it's very popular because of this shorthand and one line, so it can suit for some scenarios. But let's look under the hood. So what does this exactly mean? So we have also the class of which has the implementation of equitable, but let's look at the properties, and the properties here are still public, but these properties are get init instead of get set. So these are not fields, these are not get set properties, these are just get init properties. So which means that, and these fields are also read-only. So for example, if we look at this, look at the fields, we do not see the read-only modifier, so on the field or on the property, but on this one we see the read-only on both fields, which means that this one could be modified only by its recreation. So for example, if we use, let it be example this one, and like this, but yeah, not this one but this. Yeah, so what does this mean exactly? So here we are not modifying the field or property just like here. So for example, like yeah, misspelling, yeah. So here we are just updating the property of this this sample of the class, but here we are creating the new object based on this one with the dated field or property using the with keyword. So it means that we are reallocating the memory, we are doing all the initialization and so on. So only this way we can update the record which is written in this form. So, and let's try, for example, here the feature with this primary constructor. So let it be just this one here. We still can use it as the primary constructor, but let's look at one more moment. So what's regarding the constructor in the record, for example, in this one? So in this one, let us scroll. Yeah, so it has even two constructors. So it doesn't have only one. It has the parameterless constructor, and it has the protected constructor with using the original sample of the record, which means that it can be instantiated on the base of some other record. And let's uncomment this out, and yeah, and here is just the same case. So let's, yeah, so it doesn't change anything. So just even as in the class, so if we provide the constructor with parameters, of course we lose the parameterless constructor generated by default. So, and we can also use this feature with just the record. So, and here we see that this protected constructor remains just the same, but here we see our primary constructor, which we have done this way. Next, let's talk about the struct. So let's create this struct. Yeah, I have forgotten. So let it be this way, and probably, yeah. So we can we can define this struct even this way. So, but this is the kind of a case like with this second class. So this struct does not contain any information, just the constructor, which does completely nothing. So it looks just like this. So, but as far as we can see that this feature is suitable also to the struct. So, but we have one limitation on this probably. Let me. Oh no. Yeah. So we can do it just this way, and for example like this. So let it be to be more convenient with the naming, and let's see how it's treated by the compiler. So of course we have the struct and we have this constructor. So and here we see that this property is, yeah, so this one is read-only get, and the field just remains the same. So, and of course we can combine some of these modifiers. So, and what, not modifiers but keywords, and what other keywords can be used. So in terms of class, often used keyword is the sealed. So the sealed in some particular scenarios, which was tested not one time, can improve the performance just of the C# class. So it just adds the sealed and that's it. So we can use the sealed on the record, but we cannot use the sealed on the struct. So because if we try to use, we see that yeah, that's not very suitable for it. Next, so we have sealed. Next, we can have a combination of the struct, so here, and the record. So, and this one, yeah, something weird. So let's look. So this one, if it's the record struct, so it's not the just the regular record, so it's the struct which implements the iQuotable of the struct. So, and due to additional functionality provided by the record, we see all this functionality from the record but applied to the struct. So of course we can even try to do this. So in terms of the in terms of the keywords, it's even possible to have the sealed record class, but this class keyword will be, of course, the redundant one, because the record under the hood when it does not combine with the struct is of course the class. So this one can be used, but this of course is redundant. And the probably last keyword which we are going to see is the read-only. So read-only can be applied only to structures, but not to the records and not to the classes. So it can be applied here and here. So, and read-only does apply the additional constraint of the read-only. So we need to use the additional constraints. So this one is a property and this one is a field. And if we have the read-only keyword on the struct, we are obliged to provide the get init to the property, so it cannot be get set now, and we have to provide the read-only on the name. So, and the name looks just, yeah, we have not rebuilt probably. So the name looks just the same way as it looked, but there is kind of, yeah, so we have our name and we have our ID property with the init applied here. So, and of course there is possible form of the shorthand of this. So we can use, and let it be the ID, let it be name. So let's rebuild and see how the compiler does treat that. And this one is, so it's even possible. So that's, yeah. So public, so access modifier, read-only, record, struct, and the struct name. So, and it's a combination of, first of all, the private read-only backend fields, because these ones are properties and these ones cannot be any fields. Next, it has a constructor. It has, of course, the init-only properties, and it has all the functionality which is how to say, implemented from the record. So everything from the record is implemented just using this approach. So, and finally, let's have a conclusion. So when we should use either just the class, so let it be the sealed class. Next, when we are gonna to use the record, and when we are gonna to use the struct. So in terms of this primary constructor, we have seen that this is just the syntax sugar on the regular constructor, so nothing more, and it can be applied either to class or to the record or to the struct or to their combination. So the general concern is that the class should be used when, for example, we do not need the functionality of the record, so which is generated by the compiler, and for some reasons we cannot use the structure. So that's when we are going to use the class, and of course when the additional data access logic is encapsulated within the particular type. Next, when we are going to use the record. So the record should be used mostly in the DTO scenarios, but when the DTO does require either the comparison between the samples, and when the DTO should be printed out or presented in some default form which the record does provide. So this I'm talking about this toString method. Yeah, print members, and yeah, this one toString implementation. So when it's needed, of course, we should and we have to use the record. Next, when we should use the struct. So we should use the struct first of all when it's really performance critical, because as far as we remember, the struct instead of both class and record, which is the class under the hood, is allocated within the stack and not within the heap. So which can provide some performance benefits. And of course, the struct cannot have null values. So, and when we are talking about some scenarios with high probability of the null reference exception, of course, there is an opportunity to use the struct instead of the reference type. But in some maybe generic cases, when the functionality of the struct is not strictly required, of course, we should use either class or record. And of course, we can use these combinations of the read-only record struct. So when we have the combination of the scenarios, so for example, when we are binding to the performance, and for example, we have just the read-only DTO, and we need to compare it one with another, and for example, to have the possibility of the output which is provided by the record by default. So of course we can use this one. So that's it for today. Hopefully this in-depth comparison between field, property, and class, record, and struct will come handy to you. I would appreciate any comments or ideas.